Anh đi nhà ba mà scan đâu?
Okay, right, let's continue. We start to go into principle of work and energy. Just now we define what is work already. Okay, before the break, we define what is work. Work is force and displacement. Both must be same direction to give you positive work. If either one is opposite direction, then you get negative work. This is one of the popular area we ask question. So principle of work and energy means there is a certain form of equation you need to write. For example, okay, what you see on the screen here is you very familiar. This object is moving in the collinear motion. Collinear motion will give you normal and tangent direction. And there's a force acting on the object, which is the R. R give you all the summation of the force. So you know that you can break your resultant force into tangent and normal direction. Once you have normal tangent direction, you can use the force to become MA. It become motion equation. And also the force can also make the object to move at a certain distance. When the force make the object to move a certain distance, it create work. F equal to MA is under chapter 2. Chapter 3, it deal with force and distance traveled. So in this case, you look at the diagram here, there is a force in tangent direction and normal direction. And there's a small travel of distance here and with the theta. So this one you know, you're very familiar, F equal to MA. And you need to recall one equation that you derive when you freeze the time for velocity and acceleration. V equal to ds dt, A equal to dv dt, you freeze the time. You combine these two equations, you get A ds equal to V dv. You use back the definition to calculate the A equal to V dv over ds from the equation I write on the whiteboard here. You move the ds to the right hand side. A equal to V dv over ds. You integrating. So you put in the AT equal to V dv into the equation on the top. You rearrange. You get F ds equal to mvv. F ds, what you get? Work, right? F ds, you get work. mv dv, you do integration with the v. M is the constant value, so you don't need to worry about it. It's just a constant value. But you integrate v dv, what do you get? V squared divided by 2. Half v squared, right? So in this case, you get one very familiar equation that you learn in physics. It is work equal to half mv squared. What is half mv squared? Kinetic energy. Kinetic energy, half mv squared. You learn in your physics. What is potential energy? mgh. So now we deal with kinetic first. Later we deal with potential energy. So by looking at the equation that you see on the screen, on the left hand side is your work. On the right hand side is your kinetic energy. You explain this equation. Work done because of the force on the object will be equal to the change of your kinetic energy. Kinetic energy at velocity number 2 minus kinetic energy at the initial position. So if you use this diagram, your free body diagram, your Ft is your cos theta, right? So your force in tangent direction is cos theta. You recall the definition of work in the R and the S just now. You substitute back. So this one, force and distance become work, and it become the changes of kinetic energy. This one is principle of work and energy. Again, this is the first principle you learn, and don't confuse with other principle. This is called principle of work and energy. What is work? What is energy? Basically, it asks you the summation of work will equal to the change of energy. In this case, what is the energy? In this case, the object is moving, and without any reference of height, then it's fall under kinetic energy. You only deal with two energy in this module, kinetic and potential energy. Potential, you know that it deals with gravitational, acceleration, and h. This diagram or this object do not have h. There's no change of elevation, so you don't need to consider potential energy in your calculation under principle of work and energy. If the object is moving, then they sure will have kinetic energy. So kinetic energy 2 minus kinetic energy 1. Recall what is kinetic energy? Half mv squared. Is the first. So what kind of how the question asks you, or how we ask you when you want you to use this principle? The question will be very direct. By using your understanding in principle of work and energy, solve something. It will be very direct. We will use the word principle of work and energy, meaning we want you to use this general equation. Normally, when you write this one, you cost you about 2 to 3 marks for that equation alone. Right. So this is the elaboration of what is half mv squared. All right. In this case, we still at particles dimension. Particles direction. Later, after week 7 or week 8, we'll go into rigid body. We are now at particles. I need to mention, the work here is the summation of all the force. Summation of all the force done on the object. So if you are dealing with sometimes you can rewrite the equation to find the kinetic energy at the second location. You can rearrange the kinetic energy initially plus the change of work done will equal to the kinetic energy at the last location. This one is to find the final velocity normally, because if you look at the principle of energy and work, the second one is missing, is always the velocity. The velocity will be missing. So you rewrite this equation, and then there will be missing parameter that wait you to solve. Now, again, just now we work with force. We have friction force. Because friction force also can create work. So if you look at the diagram, the object moves from the left to right, and there's a force acting below the contact surface. In this case, the friction force will take the same form, but the work done will be negative, because friction force always act opposite direction with your motion. Make sense? Yeah. So in this case, if you write the principle of work, right? Principle of work. Let me see. Okay, I hold this information. Something wrong about this equation. Something wrong about this equation. Right. So let's look at how we apply the principle of work and energy on a slanted vehicle. So you're given an M. When you're given M, normally we will expect you to have weight in your free body diagram. Travel down 10 degrees pathway or road at a speed of 6 meters per second. You're given the initial velocity. A car with the mass and a velocity, again, kinetic energy. So, what else is given? And the driver press the brake, cause the wheel to lock, and determine how far the tires keep on the road. So you press the brake, and then the car will continue to move. Coefficient friction was given. You draw free body diagram. We move from one point to another point. So from A, move down to here. Will be S with 10 degree, and then you put in the free body diagram, which is the force only. We are interested in force in the free body diagram. First force will be your weight, which is pointing down, always pointing down vertically. What else you have? You have friction force and contact surface, right? And A, and friction force in the opposite direction of your automobile or object. Okay, so you can have all the force. So from here, you need to consider the work done. The work done, what I mean by work? Work is a force multiplied by distance traveled. How many force you have in the free body diagram? We have 3, but the normal force do not do any work, because it's always pointing 90 degree to your distance traveled. In this case, your weight pointing down, it do positive work. Why? Can you explain? Why the W is doing positive work and not negative work? Why? Why the W doing positive work? Why? What is the definition of work again? What is the positive work? When your force and distance traveled is same direction. So if you split your W into this direction and that direction, so this direction will go down, your car is moving down, same direction with your S. So you get positive work for the W. In this case, move down. It will be different if your car move up. Huh? Okay. Friction force will be negative work because it go against the S, your displacement. Okay. Then the rest you just apply equation of equilibrium in normal direction. This is normal to the road. Normal to the road means go up. Go up. So you have NA minus your gravitational force, which is mg cos theta, equals 0. Okay, then you can find your normal force. Why you need calculate normal force? Because you want to solve for your friction force. Friction force equal to NA multiplied by the friction constant. You get the value for friction force. Then you call principle of work and energy. What is principle of work and energy? The work done equal to the change of energy. In this case, there is only velocity. And in this case, we do not consider the gravitational force. In this case, ignore that another part. So we will have this equation. Of course, you rearrange, you get the same form. So you have T1 plus the change of work equal to T2. You substitute all the value. T will be mv square. Kinetic will be mv square, but 1 is the initial. What is the work done? How many force you have here? Friction force, weight. So weight will move at the distance s. So the s here will be sine theta, or you can use W sin. Okay, so this one is mg sine theta multiplied by s also sin. All right. You substitute all the value. In other case, the v at the second location is 0. You'll get the distance traveled will be 5 something. Okay, this is called this is using principle of work and energy. You solve using principle of work energy. The question will mention very clearly, use principle of work of energy. We are expecting to see this equation. Okay. You can solve using equation of motion. If you do not, if the question asks you use principle of work energy, you use the chapter 2 approach, you won't get the marks for that portion. Because the question very direct, it will give you direction, instruction already. Let's see if you can use the chapter 2 equation of motion to solve or not. So F equal to ma. All the force will create a motion or acceleration. In this case, positive go down. You equal all the force go down. You have your work and your friction force, and the acceleration along the route ma. You substitute the angle, substitute the friction force, you'll get negative acceleration, means it slow down, which is your hypothesis is correct. Because you press brake, your automotive will slow down. Your acceleration is negative, which is correct. Then A is constant. You can use the motion equation. It is, in this case, we are interested to know the velocity, the distance, right? The distance. You know the final velocity 0, the car stop. The initial velocity was 6. Acceleration you calculated -3. Distance you traveled s minus 0. Get your distance same 5 point something. Both give you same answer, it depending the instruction from the question. If the question do not mention anything about principle, you use equation of motion. If the question asks you to use principle of motion, principle of energy and work, then you need to use this equation. Need to use work equal to the change of kinetic energy. All right. Makes sense. Makes sense, huh? Okay. Now this one is more civil case. For a short time, the crane lift 2.5 megagram. In test or final exam question, we will play around with the unit. Most of the time when we deal with mass, we will use megagram. But in your calculation, you need to use unit SI, which is in kilogram. Okay, take note on that. We are given a force in the equation 28 plus 3s. S is the time. Kilonewton. There's a kilonewton K there. So in your answer, there's a 10 power 3. Determine the speed of the beam when it was risen 3 meters from the position. Also, how much time it takes to attain the height starting from the rest. Sorry, given the S equal to 3 meters means the height is 3 meters. The rope, the crane rope, you turn and then the rope travel 3 meters. So how do you solve? You are given the force, right? You are given the force. So before the start, S is 0. The crane must give some force to lift the thing. So the force will be 28 kilonewton to start lifting the object. Then you check the W. If you lift object, if you draw free body diagram, the force and the weight must balance. If force and the weight is balanced, there is no movement. If the imbalance of force is either move down or move up. So you need to check whether the object move up or move down. You check the weight. You're given mass 2.5 megagram. You need to change to kilogram. That's why you see 10 power 3 there. G 9.81. Throughout this module, use G equal to 9.81. Don't use 10 unless the question mentioned 10 in the question. You'll get 24 kilonewton. Your force is more than your weight. Then you can do work, or the object will move some motion. F equal to ma. The object will move. In this case, the object will move up. Because of force, we assume F go up. This is just a early determination on explaining whether the motion go up or go down. Okay. So there's an imbalance of force, then motion will happen. You draw free body diagram. In this case, you see there's a two rope at the two side of the object there. So there's a triangular there. There's a two rope at the side and the object. How you draw free body diagram? Weight always pointing at the center gravity or center mass of the object. And the force, if you do this diagram, the force will always go through the center of the structure. Okay, so the force and the weight will have the same direction, same axis. Okay. So you use principle of work to solve. Although this tutorial question do not mention to use principle of energy and work, but you can use principle of work and energy again. So how do we do? So in this case, you look at the diagram, there are only two forces. Each force will create work. So you calculate the work done by the force and the work done by the weight. Then equal to kinetic energy, N and minus the early kinetic energy. T kinetic energy 2 minus kinetic energy 1. So you write the principal work on energy equation. You can write all the sum of the work equal to T2 minus T1. Also correct, or the one that you see on the screen here, also correct. The one equation you see here is to give you conveniently to find the velocity for the second one, for the N position. Okay, you put in all the equation related to the energy and work. So you first one, the energy, T1 is your kinetic mv square. The work, how many work you have? You have two force, so you have two work. You have a positive work done by the force because force pulling up, the distance traveled is going up. So two vector, same direction. You get positive force, positive work. But the weight here, W, weight is pointing down, but the object is moving up. So different vector. Work is pointing down, but the displacement is moving up. You get negative work. So you have FDS for the force and WS equal to 1 over mv square. Why I have an integration here? Because my force is in S function. Previous example, you see the force here is a constant value, but you are given information that force is in terms of distance. You need to use integration sign to integrate the distance traveled. Okay, so this is the mathematic trick lah. Yeah, when you're given an equation, there's an integration you need to use to calculate the total distance traveled by the force. Okay. First one, the beam do not move from the early stage. So the first one, MV1, you draw an arrow, you write 0. Okay, in your working, don't straight away write 0. Means I don't know what mean by 0. You need to write the half mv square, then only you cancel with the arrow, you write equals 0. Don't you write the principle of work energy equation, then straight away you give 0. I will put a question mark. Why suddenly 0? Okay. You substitute all the value. You do integration. You will get velocity is a square root because v square over here. You'll get a square root of something, but still in a S form. So you're given the S is 3 meter. You want to look at what happened to that location. You substitute the S there, you find your V. V, we pick the positive because we assume it go up positive. Velocity go up. That's why we don't take the negative root. Then the time. Again, the time you can use the definition of velocity, VDS. VDS, your V equal to the equation you see just now. Then you do integration. You do integration, you move T to the left-hand side, move D1 down. You will have integration procedure. You move here and there, rearrange the equation, you get the time. Okay, I will not go into this one. So reference answer for you, time is 1.79 seconds. Okay. What is the most challenging part when you do chapter 3 question? Is the positive negative sign. and you might missing some forces in your free body diagram. That is the most challenging part. Then the rest, you just follow the mathematic procedure. Okay. Okay. Example 4 will be another case. Ignore the 2 arrow first. 40 kilogram boy slide down the smooth water slide here. Slide down from the top. Again, you see there's a parabolic shape here. Y equal to 0.75 x squared. There is a collinear motion. The R is not given, or the rho is not given. You're given Y. So normally you need to calculate the rho lah. Okay, you need to calculate the rho. You integrate one time, integrate two times, then you substitute back, you get the rho, the radius of the curve. What radius of the curve? You need to find the acceleration in normal direction. An equal to v squared divided by rho. Okay. And also from the diagram, you can draw tangent and normal direction. You need to determine the speed b and the normal reaction exerted on the boy at that position. This question you can solve using chapter 2 chapter 2 approach with the F equal to ma, split into normal and tangent direction. Or if the question insists you to use principle of energy and work, then I show you how to do. Free body diagram. So slide down. There is a contact surface between the butt and the slide there. Normal tangent. You familiar? So the weight will always go down. There is an angle of slide down. So there is a weight mg and there's a normal force at B then. Okay. So what is the difference between the second one? The first one is on the top when it slide down. This left diagram is on the journey from A to B. But when it reach B, your weight and the normal force, they are acting at the same normal axis. Make sense to you? Yeah. So we analyze the principle of work and energy. So you write change of work will equal to kinetic energy number 2 minus kinetic energy number 1. Or you can write the same as on the screen. T1 plus energy equal to T2. So you write energy, kinetic energy at point A plus the change of energy from A to B equal to kinetic energy at B. Then you start to analyze. What is kinetic energy at A? What is kinetic energy equation? Half mv squared. What is the speed initially? Start from rest. So you can cancel 0. The TA is 0. What is the energy? What is the work done from A to B? How many forces you have? 2 forces. Normal and weight. Both slide from A to B. What is the distance traveled? Okay, you need to find. So traveled, the interest point is the butt, the contact surface. How far the butt is traveled from A to B. Then the kinetic energy of B, you need to find speed when you reach B. You substitute the energy. So normal force normally do not create work, but in this case, the weight, Wmg, is giving you positive work. Why? Again, why? Going down, and you can split this one vector into normal and tangent direction. Tangent direction will give you positive work because same direction. Then you substitute all the value. There's only one missing parameter, which is the velocity at the point B. Then you find VB. This principle of work and energy is much faster when you want to find velocity compared to chapter 2. Chapter 2, you break your acceleration into normal tangent, then you only apply back to the tree of the equation. It's not slower and longer. If you use principle of work and energy, you only consider energy and work. If you want to find velocity very fast, you use principle of work and energy. Okay. So at B, equation of motion, F equal to ma. You sum up the force in normal direction, NB positive because pointing up, mg negative because going down, and normal again v square over rho. You need to calculate this value, rho equal to something. Every time you're given y is something, y equal to ax square plus something means that you do not see any radius, then very high possibility you need to use this equation. You need to call this one out in your solution. Okay, you'll find the radius is 6 point something meter. It's your homework. You substitute, then you can find this value. Again, your reference axis is at B. Reference axis at B, 10 meter, x to A, and 7.5 is there. You substitute, you find your NB. NB, you can put in the raw form, which is 1275, or you can simplify it into kilonewton. Okay. Example 5, I do very quickly. Same principle, watch the steps. You are having pulley system. Pulley system, what do you recall? The total length of the rope first. Total length of the rope, first why you need to find total length, you want to find what happened to A and B, whether it's the opposite direction or not. With the total length, you can find V, you can find A. Then you substitute back. Why you need V? Because based on principle of work and energy, you are considering kinetic energy, half mv squared. You need the V. Okay, so first block AB mass 100 kilogram. So B is 100 kilogram, A, and then determine distance B traveled when it released from rest to a point where speed become 2 meters per second. You drop B, A will go up, right? So you need to prove the relative motion using total length, and then time differentiate, time differentiate. You draw free body diagram. That's what you see on the screen here. I will skip, I will skip all the derivation, but I'll give you the final answer. So you draw free body diagram. Free body diagram means you deal with all the force only. So you have tension cable, T, you have R1 mount on the wall, R1 mount on the wall. The weight pulling down, mg, and mg for A. Then you use free body diagram to do the principle of work and energy. You substitute. Here you have two objects. What happened to your free body what happened to your equation of work and energy? Each body will give you one set of work and energy. In this case, as you see on the screen, your kinetic energy A and B is considered. Then the work from position 1 to 2, you calculate, and the kinetic energy for object A and object B also considered. You substitute, you change the kinetic into mv square. What is the distance? What is the work done by the body? You have two bodies, so you have two work. Right? You have two bodies, so you have two work. B, what is the work done? Remember, refer to datum every time you have a pulley system. B will move down, so B positive. A will move up, so later you will get negative work for A. Because datum positive go down, but you release B, A will move up. Distance traveled is negative compared to the weight going down, right? So first you cancel, A do not move, B also do not move, because both is rest. So basically this is the bonus point lah. Either you know or do not know. So cancel 0, cancel 0. Normally student will stuck here. They don't know how to move forward. The keyword is both objects start from rest. Okay, then you have the change of distance traveled between the two bodies. You continue to link what you learned in your pulley system, total length. You differentiate, you get the velocity between A and B. You get your A. When you know your velocity of B become 2, you get your VA. Once you get your VA, you know your VB. Substitute back to the equation just now. Here. Substitute back. You get your SA, SB positive. Why? This equation give you the SB already. Okay. This is how you do it. Okay, we stop here. Next, we look at power and efficiency.